One of the primary application area of neural network in general and RNN in particular is in this domain of natural language processing. As I already mentioned, right, CNN is to images, probably RNN is to natural language processing. And if you have any natural language processing, then RNN is a very, very good architecture to process that. And their spans are like different types of problems that you can do using natural language processing. And I have a scale from easy to hard problems. So you can do language detection, you can do sentiment analysis, you can do speech recognition. In the speech recognition, you're basically talking to a mic, which is a sound, and then that sound is automatically converted into a text, right? So if that's the speech recognition. Question and answering, chatbots, and we will talk about chatbots in a little bit. That's also somewhat hard. Text summarization. There are a lot of people who are working right now on this fundamental problem where you have a large corpus of text and you need to summarize that in an intelligent form, in a form that is human interpretable. We as a human are capable of reading a large amount of data and summarizing that very, very beautiful in summary, right? Now people are trying to develop these algorithms based upon, natural language processing. So typically this will be using some sort of recurrent neural network for sure that will take a large corpus, maybe sheet of 15, 20, 30, 50 pages, and then give you an automatic summary of what is there in that document. And again, so that kind of work is going on. And then the machine translation, right, which is a popular application that is always there, already present, right? Automatic speech recognition and so on. Those kind of problems are happening. Machine translation is also taking one language and translating it to another language is something that people are working, and there are a lot of apps that already does that. So this is basically the spectrum from easy to hard problems in the domain of natural language processing. And in all these problems, what we have listed here, which is language detection, speech recognition, sentiment analysis, text summarization, machine translation, you are essentially using an RNN algorithm. And by de facto, for any natural language processing, probably RNN are the best type of neural network architectures that you can use. So here are some of the specific use cases in natural language processing that people are putting and the businesses are doing, right? So this is the Google Cloud Natural Language API. Okay, so what it does is this API is basically you can try, and this is something that you can do. Google has this. You can take a customer review, for example, someone who has bought, let's say headphone from Amazon. He has provided a review on the Amazon. You can take that and you cut and paste, and you can put that in the API, and you can search analyze. And it will give you the score ranges of different sentences, whether that's a positive, negative, and then the overall summary for this review that you have. Okay. Now you can use this API and you can include that in your website, and you can see how many customers are automatically. So let's say if you're getting thousands of reviews, you may not have time to read through all of those thousands of reviews, right? But do you know whether your product is right or not? And that you can do through the sentiment analysis type of analysis, which could be enabled. So you can write a code which basically, whenever a review is coming, you can hook it up to this Google Cloud and get basically an output of whether that review was positive or negative or neutral, and that will help you in assessing what your customers are thinking about your product that you might have. So this is an example. We are given a set of sequence of sentences and predicting whether that is a positive review or a negative review is a class of problem known as sentiment analysis, and this is where the recurrent neural networks are essentially a primary algorithm. Okay. Language translators, and these are becoming popular now. Especially it was just growing up before the pandemic. You can see a lot of different apps like iTranslate Voice. Google has its language translator, and then there is a Say Hi Translate, and there are others. These are the three translators that this is very, very popular right now. But there are other ones that are popping up nowadays, which has this good capability to do language translation. So what you do is, let's say if you have installed this in your cell phone, right? you can speak, let's say, in Hindi, okay, and you can ask the language translator to convert what you have spoken in, let's say, German or something like that, if you're traveling to Germany. And then you can show it to a local person and he can understand the German and he can help you with the direction or something like that, or this can help you in a conversation with other people. Now this translation where you're taking English and converting that to a Spanish, or you're taking Hindi, converting that to a German language, right? This is basically a class of problem known as language translation. And as I already mentioned, RNNs are the best sort of neural networks for doing this language translation type of problems. Okay, and again, I translate, say hi. Their main business is doing this language translation. So their main business is essentially implementing very effective RNNs for doing the language translation. And again, not only RNNs are important, you also need to have very good capability of pre-processing, having data, labeling that data, and then integrating the various different data sources so that you can create a clean and nice and a very effective machine learning algorithm that does real-time language translation. So there are other facets, other aspects of the technology that is there, but the central aspect here is probably the RNN that you need to take into account. Here is another one that you might have come across and probably used in your daily life, which is known as the personality chat box. So nowadays, when you go to a website, right, automatically a chat box will pop up that will do conversation with you. So these are known as conversational chat box, intelligent chat box, or personality chat box, because they have a personality based upon a machine learning algorithm that is underlying them. And they basically, when you converse with them and when you type some word, they have automatically reply you with certain specific word. And what they're doing, if you think about this, what is the problem? You're providing you input in the form of a sequence of word. What they respond with a sequence of word as an output. And essentially this has been implemented using an RNN type of architecture. And a lot of this personality chat box or any chat box that you see across has been implemented through machine learning algorithms, and mainly this is a sequence to sequence modeling problem where this input is a set of words and output is also a set of words that you can use, right? So this automatic interaction is enabled by essentially a machine learning that you have. Okay. So here is typically what you will see in a personality chat box that we have, right? So you will have, you will be taking some messages, right? It will be processed through Java. Then, right, you might have access to some APIs that has been provided by companies like IBM, Google, or Amazon, where you have this conversational language model, or they have created you a model which is already learned. So one of the beautiful things that I want to mention with respect to this slide is you do not probably need to train your own language translator, or you do not need to do your own input to output mapping. All of these big corporations, they are selling this as a service where you can access their API, where they have trained it over a huge amount of data, and they are fairly accurate algorithm. You can give the message that you have received in your chat box, and you can pass it on to their API, and you can retrieve what is the output of that API, or what is the output of that trained model that is here, and then you can bring it back and you can display that to the person. So what you're doing is, like, maybe you have implemented a chat box, but you do not need to implement the overall technology at all in your end, and you do not need to hire anyone. You can access the language translator. You have to pay a service for that, but you basically access someone's developed code, already good code, which is responding to what the set of words that has been input in your chat box, and you can integrate that to create your overall app. So again, this sort of things, personality chat box are very, very easy to implement. Only you need to do is you need to get the input from the user and then pass it on to already established, learned very good models on Amazon or Google or IBM, where you can buy their services and they will give you the response that you need to provide to the user. And this way, you will be able to basically customize your applications and so on. So again, personality chat box, or if you have interacted with this intelligent chat box that immediately responds response to you and give you a great answer, you can see the power of the recurrent neural network coming in front of, because essentially a recurrent neural network is doing that.